And now we're ready to start the final technology module for technology and leadership. And this module covers a very common and well-known technology, one that we're all personally familiar with, the idea of mobile computing. We all use mobile computing and we have been using it for many years now. Most people have a smartphone and some people have smart watches, and these are all examples of mobile computing. If you look here, I've just put a couple of images of some. We have on the left there an American Airlines app. American Airlines deploys mobile apps for their customers so their customers can manage their own reservations, get their own boarding passes, make new reservations, and reach out and get help in the case of a problem. And then to the left, to the right of that, you see what's actually the Walt Disney World My Disney app. And Walt Disney World now does almost everything through the app, including allowing you to enter your resort hotel rooms, make reservations on rides, make reservations at restaurants, purchase things ahead of time. It's an all-around customer experience app. And so this is one way in which a lot of companies use mobile computing. Of course, this is more customer focused. There are also a lot of ways in which mobile computing is used internally with custom apps, and we'll look at a couple examples. Mobile computing refers to the use of mobile computing devices. You kind of say, well, that's a duh. Things like smartphones and tablets and laptops and also wearable devices. And what they do with those, obviously, is they perform computing tasks while people are on the move. Now, that could be someone who's on the move around the inside of your company, or it could be someone who's on the move around the countryside. Maybe they're a service technician that moves from one place to another, or it could be customers who are on the move, and you want them to be able to get access to their data. Amazon obviously is big on this as well. They have an app, and you can shop anywhere you want. And I've done that many times where I've been out and about and thought, oh, I saw something in a store I'd like, and I quickly went on Amazon to see if I could get it cheaper, and then I was able to know which way to do it to save the most money. I've got a couple examples here. You could have a waitress who, instead of writing her orders down on a piece of paper and then passing that back to the kitchen, she has a tablet there, and she takes orders on the tablet. And I've seen this in several restaurants that I go to on a regular basis, where they have a tablet, they put the stuff in, and it gets electronically transferred back to the kitchen. The order is automatically queued up. And if you think about it, not only does this make it a little easier and cleaner for the waitress to get the order back to the kitchen, but it also gives the restaurant the ability to monitor a lot about what's going on in that whole process. They can monitor when the customer first ordered their drink, how long it took between the drink order and the main meal order, how long it took the kitchen to finish it, because when the kitchen finishes the meal, they're going to do something on their end that will notify the waitress that, hey, this meal is ready for you to come and pick it up. So they can get a lot of metrics about how the process itself is working. Not only does it potentially make it nicer for the customer, but it also makes it possible for the restaurant to measure its efficiency and make improvements and identify areas where there are improvements. I have a friend of mine who works for a startup in Dallas called Theatro. And Theatro makes a small wearable device. It actually looks like a little Star Trek communicator. I don't know if you're familiar with the show Star Trek, but that was a space show, and they had these little kind of triangles on their lapels on their shirts. And they would be able to tap it and talk. And that's exactly how this Theatro device works. And what happens is employees in retail stores like Walgreens or Walmart or something like that, they can be out on the store and the customer asks them a question. If they don't know the answer, this little device has AI embedded into it, and they can talk to the device. The device figures out how to answer their question by either going to corporate databases or connecting them with a corporate expert. And then they can have a voice conversation. This is a fantastic example of mobile computing that does not involve a display screen. In fact, they specifically don't put a display screen on it so that the employee who's out on the retail floor will have an eye contact while they're getting the information that they need. And so there are a lot of ways in which we can be very creative in terms of the devices that people have, custom devices like Theatro's device. You can go look that up on the internet if you're curious about it. Most airlines now require a mobile app. I fly on Southwest and American and British Airways, and all three say that you have to have an app. Delta is the same. If you want to watch a movie, you have to have the Delta app. And so a lot of these apps have to be downloaded. And when we do that, it allows individuals, whether they're customers or people inside our company, to access information, communicate with other people, perform tasks. It allows the company to monitor those activities and gain metadata about the behaviors and processes and how they're being executed. And so, ever since the smartphone came out, people have begun to figure out ways in which they can use that or similar devices to provide faster service and better information about how the service is being done. Now, what are the key elements involved in mobile computing? When we think about mobile computing, a couple of things jump to mind immediately, and many things you might not think of directly. First of all, there's the hardware. Are we going to have we're going to have phones, potentially tablets. You might have watches. Now, IoT, we talked about that earlier. IoT will overlap this some. Not all IoT devices are considered mobile computing. Really, we're thinking about things that are on the move, but things like the Theatro would be a mobile device. And you could have an Internet of Things device that a person wears that monitors and gives them information as they go, like a smartwatch or something like that. So there are some IoT devices, but don't think they're all like that. Of course, every mobile computing device has to have some measure of software, and mobile apps are a whole different branch of study. I have a professor here down the hall who has his own little private business that he develops mobile apps, and of course he teaches a course here on how to develop and build them. And they have a different set of requirements and some unique constraints that you need to be aware of. For instance, the screen size is one, but also there is a higher expectation for immediate response time on a mobile app. When we're using our phone and we tap on something, we expect it to respond right away. And so mobile apps have to be developed in a way that can be highly responsive. If you have ever written an Android app, and I have written some Android apps, they actually, inside the coding, the Java coding and system calls that you can make, they actually put certain requirements on you to force you to write responsive apps, because Android themselves, Google does not want their product to look slow if you're a bad programmer. And so the software that people write on for mobile apps are a whole area that you could spend time looking on and gaining expertise on. The unique nature of the interface does require us to think about it in a slightly different way. Not only is it smaller, so the screen has to be organized efficiently, but as I said, it needs to be more responsive. Many mobile apps are custom made, and we're going to look at those in just a second. There are three types of mobile apps. Of course, we have network requirements. Usually, I think most of us, I know I do, think about cell phone service, mobile data like that, like 5G from somebody like AT&T or Verizon or Bridge Telecom or somebody like that. That's not necessarily the case, though, for all mobile apps, because we're not talking just about mobile moving about a wide countryside from city to city. Rather, we're talking about somebody who is moving. And so that could be somebody who's moving about a restaurant, as we talked about, or about a factory floor. There could be a lot of different ways in which someone is moving. And so it might be a Wi-Fi connection, or it might be a Bluetooth or a Zigbee connection or something else like that. But all of these apps typically require connected communication. They do not typically work independently. Now, some might, but I think probably the vast majority do not. Do require some sort of connectivity. Some examples, I found this example of field service technicians for utilities like the electric company or the gas company. There are some companies that have provided their field service connections mobile tablets, and the tablets have 5G cell service, and the person out in the field can receive work orders on the fly. They can schedule their own appointments. They can update job statuses. And of course, that also will allow them to communicate and coordinate between maybe many technicians. If there's 2 technicians required for a job, they can work together using their mobile computing device to more seamlessly schedule that. They don't have to go somewhere and meet or get on the phone and try to work it out. They can do it right there on their mobile device. And again, I can't overemphasize from a company perspective or an organizational perspective, the metadata that you can pull from the way in which the employees use these devices. The devices themselves give us a lot of information about how the employees are working. We can see who's getting what done, how fast they're getting it done, who's the most responsive, and we can also see things like are there problems with getting a person from one place to another? We can track employee location. There's so much information we can get out of this. This could actually be a source of information coming into a big data pool. We talked about big data earlier this semester. And just all that meta information about the employees and the way in which they are working and using the app is also available. And that is a tremendous advantage to your organization. All right, there are more than just these two, but these are like, 99 point some percent of, I didn't look that number up, so I'm just throwing that out there. 99 point some percent of the apps either run on the Android operating system, which is the one from Google, or the iOS operating system, which, as you can clearly see here, is the one from Apple. Now, I just want to say something here real quick, take a minute, and I think it's important for us as technology leaders to be cognizant and mindful of this. It's very important that you don't become strongly and emotionally committed to some technology platform. That is actually a very big mistake that a lot of people make. They become kind of identify with, say, Apple or Android, and it becomes their system and it's their choice all the time, even if it's not the right one. In fact, what I recommend you do is that you be technology agnostic. Never get yourself into a place where you always think that the Apple choice is the right one or that the Android choice is the right one. Always be open to reviewing these things and set that as an example for the other people in the organization, that you're not going to be, quote unquote, religious about this thing. It's going to be a non-emotional decision as much as possible. And it's not always 100% possible. We're humans and we do have things that we prefer and things that we're comfortable with. But use the message here is use the right tool for the job and be willing to evaluate between options when you have them. And I've seen this all through my career in technology, which has been over 40 years now, that people get committed to a specific kind of technology and they end up deploying it and using it in a space where it's really not the best choice. And then they regret it later. One of the things that you can decide early on in your career is to say, I'm going to be technology agnostic. I'm going to try to weigh the various strengths and weaknesses of my choices and then try to make the best choice as rationally and unemotionally as possible. Now, if you have your whole company invested in Apple and you're looking at a new solution, the fact that you have so much already invested in Apple will influence your decision because you'll say, we already have expertise and stuff like that. So certainly that's part of the thinking. But don't be committed emotionally to one side or the other. Be willing to change and evaluate them as much as possible. Having said that, here are some of the strengths and weaknesses of iOS and Android that I've highlighted here. iOS is considered by many, many people to be a more consistent and higher quality interface, easier to use by a lot of people. And that's partially because Apple puts a tremendous amount of emphasis on the interface and how it's going to be used. And because they have complete control over it, they can actually demand that. And so they can sort of hold a high bar. Android, on the other hand, is much more flexible and developers can do a lot more, which also means they can write some code and apps that are not quite the same high quality. Because Apple is completely in control of iOS, they kind of have it locked down. They have a much better control over that. And because of that, they can have better security. And a lot of people think Apple is a more secure environment. Now, they're both vulnerable, but a lot of people think Apple is a more secure environment. The apps on the Apple iOS system have a stronger reputation for being easy to use and having quality. Now, the downside of all that control that Apple extends over their marketplace and their ecosystem is that there are far fewer choices. You have fewer hardware choices, you have fewer software choices, you have fewer choices in terms of things like how much memory you need on a device, or what kind of processor you need on a device, or what kind of radio you're going to have on a device. If Apple doesn't want you to have it, you're not going to have it. If they don't want you to have a blue one, there is no blue one available. You're not going to get that. And because of that kind of monopoly that Apple has, they typically demand a higher price. And some people will say, well, the quality is worth it, but that's still something that you have to take into account. The Apple product is very expensive. On the other hand, Android, because they don't demand total control, they have a much wider range of devices, and that introduces, they actually have competition within their ecosystem, which drives innovation and also drives lower cost. And so with the Android platform, you may not get what is perceived to be the same high quality, but you may have a much broader range of choices in terms of cost versus functionality. And that can be a real advantage to you if you're looking for a lower cost solution, or you're looking for something that has a specific platform, like a certain amount of memory or a certain speed processor, things like that. Also on the Android platform, there is much better capability for high customization, not only of the apps, but also the operating system. You'll find companies like Samsung taking the Android operating system and then putting their own layer on top of it, kind of their own interface. And some people like that, some people don't. But the fact is the option is there, and that's something to think about. All of that competition also usually leads to a lower cost. Now the downsides are that the quality varies much more. Many people think that they are less secure because of their more open nature, and you can definitely have an inconsistent, user experience from one device to another, from one manufacturer to another. So these are your mobile operating systems. You need to be aware of those. Here we are again, back at the security slide. Everything we're going to talk is going to be affected by security, and we're almost always going to have to consider the security of that. Most of the security threats that you see in other computing platforms are certainly present in mobile computing. But there are some threats that are magnified, that are much, much more likely because of the mobile nature of these devices. And the first one is obvious. The devices could be lost. They could be lost by oversight from an employee or from the owner, or they could be stolen. They're easy to pick up and walk away with. Just this weekend, I was shopping at a retail store, and they have a person at the store who checks you out to make sure you're only walking out with the stuff you bought. And that person had left they had a little table behind them, and they had left their phone on the table, and it was like 20 feet from where they were working to their phone, and everybody walking out the store went right past their phone. And I looked at the phone and I thought, that would be so easy for someone to steal, and the employee would never notice it until they finished their shift and went over to pick up their phone and realized that thing disappeared at some point. So that's a fact of mobile computing, is that there's a possibility of lost devices. Now you mitigate that by having excellent passcodes, maybe using biometric authentication. You certainly want to have stuff encrypted, and there's a very common policy called remote wipe. And so if an employee says, hey, my tablet's been stolen, the central support department should be able to send a signal out to that device and have it wipe itself out, have it erase all the memory cleanly so that nothing can be retrieved from that device. That's a standard policy that you should be thinking about implementing if your corporation or organization does not have it. Also, sometimes people with these devices use unsecured Wi-Fi, like public Wi-Fi at a Starbucks or something like that. And we need to find ways to mitigate that. Typically, we'll use a VPN or something that will cause it to be encrypted before it leaves the device, and that will provide a high level of security. But you just have to recognize that your conversations are not private, so you have to do something to secure them. Also, there is the idea of data leakage through applications. Now, this isn't so much that the data in the app is being stolen, but rather that the app itself can be collecting data that you're not aware of. And TikTok is a great example of this. I don't know where you're at in the TikTok conversations. I have worked for the United States federal government in the past, and even before it became a big deal in the last 2 or 3 years with the United States President Trump, already within the Air Force, they were very concerned about TikTok. They realized and figured out that it was gathering information from the phone use itself, gathering information from the location of the phone, gathering other information from the data on the phone that wasn't secured, and it was sending those to databases from foreign adversaries. And so already within the Air Force, they were very concerned about that. Now, it might not be TikTok, it might be something else, but you have to be aware that there are other programs running on these devices that you may not have control over that might be collecting meta information about the usage of the device, or where the device is located, or how the device is being used, things like that. So you have to be thoughtful about that and take ways to mitigate it. Finally, because the devices are small and can be stolen, they can be subject to a direct physical attack. In other words, the person has control over it. They can take a little paper clip and reset it, hit the reset button, hold it in. They could jailbreak the phone to get past security authentication. Anytime somebody has direct access to a device, then it's possible for them to have backdoor or reboot or jailbreak access to get root control and then get to other bits of information, which is why you want to have, remote wipes. You may want to containerize corporate data so that it's held in a secure, encrypted subfile on the operating system itself. There are a lot of ways you can mitigate that. You need to be thoughtful as a technology leader. All right, let's end this by looking at a couple of slides around mobile application development. And there are three kinds of mobile application that we develop. One is a native, and that's basically a program that runs directly on the device. One is a web, and that's when what we're really using the device to is access a program somewhere in the cloud. And then finally we have the hybrid, and that's where I have a local application that also accesses cloud applications. And so that's a hybrid. With a native app, you have an application that's developed for a specific platform like iOS or Android. And it will be developed in a specific programming language, typically in Android. That's the one that I've done some development for. It's going to be Java, although you can write in other languages for Android as well. But it might be Java, for instance. I think what I've seen from people who are doing Apple development is they have used a version of C language that Apple provides. The native apps, when you run them, they're local on the device. So you're running it on the local processor. It's accessing local memory. That doesn't mean it isn't communicating data or fetching data from a remote location, but all the work is being done locally. And the app is built and customized for the local device. Now, one of the nice things about it is because it's running locally, it has access to the local sensors and actuators that are on the device, things like the GPS or the accelerometer, which tells you if it's moving, or the camera. You can have a local device, get to that stuff. The apps in a native mode are typically integrated. They're tightly bound to the device and its features, which also means that they're optimized. So there are a lot of really nice advantages for running a native app, and that may be the choice that you need given the application you have. Then there's the web app. And this is actually more where your local mobile device is kind of acting as a dumb graphical user interface. It's not really doing very much. It's simply taking your inputs and sending them off, whether it's text or taps, sending them off to a central system, usually on a web server, and that central web server will have some sort of typical data backend as well. So you're not really doing much on your mobile phone. It's really just an interface that sends data, requests, buttons, clicks, actions to some remote system, and then that remote system will, update the screen. A lot of these are built through web interfaces, Chrome browsers or Internet Explorers or whatever the browser that's on the mobile device is. And so as a result, what you really end up doing is you're really developing for a web app, a web-based application, and you're just using the device as a tiny web interface. And there's nothing wrong with that. There are a lot of apps where that is the best way to do that. For instance, maybe you have a data storage where you're keeping track of information and you use the phone where the person enters the information and it gets sent off and stored in a database that can then be retrieved by other people at corporate. If you're going to do a web app development, you've got to make sure that you're thoughtful about developing your program so that it can sense the screen that it's on and adjust accordingly. Small phone devices can be overwhelmed, and the application can be made unusable if we don't properly set the screen size and take advantage of the screen and the way that it's most natural for people to use. We also have to make sure that our devices are compatible with many different browsers, and that can introduce some maintenance overhead, but it needs to be done because you can't always guarantee what kind of browser your client is using. And finally, there's the hybrid, and the hybrid is basically both worlds. And some people think that it's the best of both worlds. Again, here I'm not going to get religious about that. What I'm going to do is I'm going to look at my requirements for a particular job, and those are hopefully going to guide me to either do a native app, a web app, or a hybrid app. In the case of a hybrid app, obviously you've got some local app that runs. Because it's local, it has access to the local devices like the camera and the accelerometer. But a lot of the work that the local app gets done, it gets done by sending a request off to some web-based, cloud-based server. And so we have both, and that's why some people think it's the best of both worlds, because I have access to all the local features on the phone or the tablet, but I'm not necessarily bound to doing all the work there. I can rely on a cloud-based, high-end processor and big data environment that I obviously couldn't put on the phone. And so if you're going to do this, you must, again, optimize the app for different screen sizes, but now you definitely have to take into effect the network delays. And this comes into play with how the app interacts with the user. You don't want to have the person tap something and then you send off a network request and 3 seconds later get a reply back, but the user's sitting there not seeing anything on their screen the whole time. You definitely want to get the apps developed in a way that it maintains a responsive touch, even if it says accessing data, please wait, or something like that. So those are the kinds of things that you definitely expect. All right, finally, we have this topic of mobile device management, and this is a critical part of mobile computing. What are you going to do to manage these devices? These devices are assets, they're tools that you and your users or your employees have access to. And so we have this idea of mobile device management, or MDM. And there are a number of actually companies that make mobile device management solutions. What they do is they allow you and your organization to secure mobile devices, to manage them, to track them. They provide a central platform that lets you keep track of everything and enforce security policies. For instance, that remote wipe that we spoke about earlier. They also allow you to remotely manage the applications that are running on this. When I worked for Cisco Systems a couple of years ago, they had such an app. They had a remote management device. I had to have a client of it on my phone, and then it made a separate container. And Cisco could access my phone and get into the container and control the data that was on there, wipe it if they needed to. And so that's what these MDMs do. One such is called AirWatch, and that's a solution that is for iOS and Android, and a lot of people will connect it to iOS. It also works with certain mobile Windows platforms. It allows you to enroll a device, in other words, add a device to the management, automatically distribute apps so the client, the user, doesn't have to do that. It keeps track of where the device is, and it will require, by forcing the device to implement certain policies, such as you must have a password, you must use biometric authentication or something like that. You can remotely force the mobile device to be configured that way, which gives you a tremendous amount of security features that you can have. Another one is called Mobile Iron. It's another MDM solution, and what it does is provides device management, security features. Some of the advanced features this one has are multi-factor authentication. So multi-factor authentication is, if you're not familiar with that, is when I put a password in, but then I get another prompt through another method, like a text message or a phone call, and that can only be sent to my device, and so then I get another number and I have to enter it again. Or I use biometric authentication and I also have to provide a password, or something like that. These kinds of features. And so basically, I've listed for you here a few mobile device management software packages, and that just gives you an idea of what's out there. These are very common ones. And you'll want to have one if you're going to have an organization that uses mobile computing. All right, that's the topic of mobile computing. Slightly shorter lecture than typical, only about 30 minutes so far. And wish you the best. This is the last technology module. After this module, please go and finish the homework. And then after that, please go and take the online quiz. Now, it's not really a quiz, it's a timed homework. You'll see that as Module 9, the timed homework. And here's what it is. It is going to be a set of 30 randomly chosen multiple choice questions that are going to cover these 8 technologies that we've just had. And it's going to pick from, I think I have about 40 or 50 questions that I've written, and it's going to pick 30 of them and give them to you. Each question is worth 1 point. You do not have to use the Respondent's Lockdown browser. You may use OpenBook, OpenNote, OpenText. That's not a problem. But you are going to have only a certain amount of time. You're only going to have 60 minutes to take the quiz. So make sure that you're well prepared and organized for it before you open it. And Best of luck to you. Please reach out if you have any questions. Thank you.